Welcome back, everyone. With the Philco Predicta Princess out of the way and the customer is happy with its performance, I now need to crack down on the Tandem they dropped off with me. This one is a little more familiar, having done most of the work on my own Holiday. The chassis on a Tandem is very similar. There are some electrical differences, placement of components, that sort of thing, but on the whole, the 9L37 Holiday chassis and the 9L38 Tandem chassis are pretty close. And they're a little easier to work on compared to the PCBs on the Princess and Siesta. So, let me bring you in to the chassis here. I haven't done much at all to this other than give it a once over, see if there's anything damaged. The high voltage tension connection, the high voltage center lead on this guy, this was actually snapped off at the base. I've already superglued that back in there. It's nice and solid. One thing that I was concerned about, and still am, is the condition of the flyback transformer. These get hot, and they melt and puddle all the wax at the bottom. The Princess wasn't so bad. This one has a pretty decent pool of wax at the bottom, and there's quite a bit of it cracking off in areas. And more importantly, the connection to the 1B3 high voltage rectifier here is kind of floating in space. All the wax around it has cracked off and still feels attached, but we'll see if we get anything out of it. I haven't ohmed out this transformer yet. I just want to try it out and see if we can get any high voltage at all. Speaking of, last time I tried this, I was able to get filament glow, but we had no B+. No high voltage to speak of, couldn't get anything out of the speaker. Flyback obviously wasn't running, absolutely nothing. On this set, the B+ rectifiers are these two diodes here in the center. Pretty easy to get to. They actually snap into 2AG, or is it 2AG or 3AG size fuse sockets? Either way. One in opposite directions. These make up a voltage doubler from the AC line that bumps about 130 volts DC up to about 275 or so. And I probed out that circuit initially. I double-checked these diodes to make sure they were good. They both check out identically, which is nice. Then I went in and I looked at the first big capacitor in that circuit. Let me pull the schematic here. So in the voltage doubler, for the B+ circuit, bear with me. Let's see. Yeah, for the 9L38. Okay, this might be a little hard to see. Our power cord is right over here. And you'll notice one connection has an X on it. That's kind of important. The other end here goes off, comes to the power switch. There's a line filter cap right there they'll need to replace, C11. That comes down and then it splits off. In one direction it goes through the thermistor, the hockey puck underneath there, for the filament string. There's a dropper resistor across the pilot light, and then that goes through the filament string and such on. The other half goes through the 5.6 fusible resistor, this guy right here. And then that goes into the 140 microfarad 200 volt cap right here, E2, before going into the silicon rectifiers, and then those head off and go through a pi filter and onto the rest of the circuit. My initial thought was that this capacitor right here, if it was dried out, would completely kill the circuit. And I did actually pull it and check it on my meter. Maybe this guy here. The Holiday has the same setup. This capacitor lives underneath the chassis, all by itself, single section. And when I put the meter on it, it read absolutely nothing. No resistance, or infinite resistance, effectively, and also about 1 nanofarad of capacitance. So this was truly well and truly dead. I didn't have anything in the 200 volt range because the ones on my Holiday were originally rated at 160 working volts. So those are what I had bought. I did have a 450 volt cap in the right value, so I installed that down there to take care of that. And then I tried powering it up, and I still got nothing. Having checked that capacitor and checked these diodes, I decided I needed to go back to the schematic and look again. And it hadn't occurred to me to check the fusible resistor, or the fusible resistor in there to protect the B+. So I put the meter across this. It measures closer to 11, although there's some oxidation on the pins. So there is resistance across here. But then I tied back to the capacitor under there because this side of the fusible resistor actually goes underneath the chassis into the negative lead of that cap. Put the meter on this end, put the other end on the capacitor, and I read absolutely nothing. No resistance between those two, well, I should say infinite resistance between those 2 points. Turns out this particular contact right here had oxidized pretty badly, and I was getting basically nothing, which meant that the AC connection to the high voltage circuit, it wasn't happening. So my hope is, having soldered these two connections to get rid of any mechanical connection problems and having scrubbed out the contacts in here, I double-checked. I have good continuity from the resistor to the cap and from the cap to the diodes. And I know the filaments all glow, so the filament string is good. And I have tested the CRT, and I know that it still has some life in it. So what I would like to do now is get the head unit plugged in to this, because if you don't have the main plug on this guy actually jacked into the set, it will not power up. 2 of the pins on that socket back there are part of an AC interlock. Without this installed, not only do you get filament continuity, you don't even get the other half of the AC circuit. The connection to chassis ground effectively goes through this plug. So it is doubly important. So I'm going to get the Variac set up, and we're going to try bringing this up and see if we get anything. No pilot light, which means this probably isn't on. Ah, there we go. And look at that. We got 200 volts of B+ already. Lamps coming on. I'm going to kill the other light here real quick so we can see everything warm up. And I can see all the filaments coming up. And our B+ is going down, so we're starting to conduct. Oh, look at that. We have a crappy bar on the screen. Alright, I'm going to give this another try here. I have a screwdriver. It turns out the second pots in the controls back here are actually only accessible by using a flathead screwdriver. I thought they were hexes. They are not. Unfortunately, I don't know which ones of these is which, so we'll have to play with them and figure that out. Those labels, of course, are on the end of the knobs. So we've got horizontal, vertical, and brightness. Shouldn't be too hard to figure out which is which. And there goes the high voltage section. And there's our bar there. I want to see... Okay, so that is brightness. That one, I'm going to guess, is the vertical control. That's the horizontal control. Okay. So if I had to take a wild guess, alright, that one does not a whole lot of anything. That one could be width. That one might be a height control. Hard to say. But that is about all I really want to do on this. So I think just bring it up. We're only at about 100 volts. I don't think it's going to get any better than that right now. So I think we're going to go ahead and simply shut that off. But that's a good start. High voltage section works. That means the flyback's not totally screwed. That's good. Tubes are all working. That's also good. Not much on the vertical section. That could just be that it's not providing a correct output pulse. That's actually probably a pretty reasonable assumption. And I say that because this board has been fiddled with in the past. If I scoot this over a little bit, we can see evidence of prior work. First off, this great big black beauty right here, that's new. This guy right here, which has been pigtailed in, that's new. Actually, it might just be those two. I didn't notice much of anything on the underside of the chassis that had been disturbed. So that was good. But yeah, odds are caps in the vertical circuit especially are probably shot. So we need to replace those. And yeah, it's a pretty good place to start. Let me get everything unplugged here. There we go. Good news is, though, it means the cord is good. Or most of it is, anyway. If I remember right, audio section is here. Vertical output section should be here. This should be the vertical integrator, I think. And then this stuff over here, this should be the horizontal, and this should be the peaking coil for the horizontal. Yeah, these are all black beauties. I'm sure they're all leaky as hell. And replacing them would probably solve the issue. But of course, this whole thing needs to be done. All new sockets. I've got all the couplets ready. And I should have all the component values I need because I bought duplicates when I did my holiday. And most everything on here is pretty much the same. But before I dig into the deflection board, I would like to flip the chassis over and start doing a bunch of work down there because the power supply all kind of lives down there. And I'd really rather get that cleaned up and done to eliminate any possible B+ issues. I don't think we're having high voltage issues at this point. It's obviously just leaky caps, but clean up everything down there, which means I'll only have to work on the top afterwards. As far as the underside of the chassis goes, it's mostly undisturbed. The only thing that I'm quite positive has been fiddled with are these power resistors over here. This whole mess of Siamese resistors and these over here, which are half soldered, half just mechanically attached, that is all kinds of wrong. I'm pretty confident that is not factory. Everything else in here, though, appears to be. All the original wax caps. There are some black beauties in here, but my holiday also had those. The one outlier, of course, is the cap that I exercised from that right there and replaced with this single 450 volt cap, added a terminal strip to the original hold down lug, and then just ran the original wiring to it. Super easy. As far as dealing with the two remaining multi-sections, this 4-section and this 3-section here, do the exact same thing I did on my holiday. 2 terminal strips. I can put one of them here, mount those 4, and then put another one somewhere in this neighborhood to get those 3. Probably have to do a little bit of routing for the wiring. May have to make some extensions. Shouldn't be too hard. But it means I can also go through here and start dealing with the few wax caps that are underneath here. Now, I don't remember which one of these is the vertical transformer. The audio transformer is also going to be under here. This guy back here only has 2 leads. Pretty confident that's the power supply choke for the Pi filter. And we have this big guy here. That's probably vertical output. This little one not really sure what that one's for right there. Yeah, that's the plan. I'm going to start cleaning up the underside here and start working on getting those electrolytics replaced. Just a quick state of the chassis update. I've been plugging away down here, and I've managed to replace all of the wax and molded capacitors. I did replace 2 of the electrolytics, these 2 independent ones down here. Haven't touched the multi-sections just yet. I want to see if we get better vertical deflection now that I've been in and done some of the caps in here, including the retrace blanking network right there. And a few caps under here are part of the vertical section. I just want to see if it improves anything. And what else? Been checking resistors, only found one that seemed off. Replaced it up there at 3.3 meg. These 3 clusters of resistors down here that I wanted to get a closer look at. It turns out, originally, Philco had a single-piece sand resistor that contained 3 separate sections. Per the schematic, there's an 8-ohm section, a 13-ohm section, and a 17-ohm section. The 17 is in parallel with the dial light bulb, probably to keep it from blowing out, because it's the 17 one is, yes, comes off the thermistor. Is it part of the filament circuit? Yeah, it looks like those are probably part of the filament circuits. Either way, the big one-piece unit, I guess, dies, crumbles, falls apart. So the simplest solution is just make up replacements. Now, I double-checked these with my meter, and they are almost spot on for the original values. However, I think they look like shit. Especially this one, because I don't know what the wattage rating is for these. I just downloaded the SAMs. I need to look at it, the parts list, and see if they give a value for this. And I think Bob Anderson also did a video regarding replacement of the sand resistors, so I need to go and look at that too. I would really like to just replace these with single units, and in order to do that, I would have to adjust them to modern component values. So the 8 might become a 10 ohm. The 17, I think 18K is the closest, or 18 ohms would be the closest there. And then for the 13, honestly, I'd have to look. 15K is what I think would be closest. There might be something else that's closer. But yeah, I'd try to find the closest modern value to those. Line voltage being a little higher and all that. I don't know if increasing the resistance of the resistor that's in parallel with the dialight bulb could potentially cause problems. More current might run through the bulb. Maybe not much, but either way, I want to clean this up. And a few of these resistors over here, like these are only rated at 1 watt, when the main body one is rated at 10. I'm sure there might not be enough current going through those individual ones to really cause any problems. But again, I want to clean it up, make it look better. Anyway, that's what I've got so far. Still planning on doing the electrolytics after this. I'll probably start with... well, I should probably start with this can, get the wiring moved around, install the terminal strip and all that, and then I'll do this one last. That one will probably be a bit simpler. But I have the ribbon cable for the CRT hooked up at the moment. I want to see if we get full deflection or even just slightly better deflection. Now I gotta remember which one of these is brightness. Oh, hey, look at that! Covers the whole screen. It's got a funky deal going on there at the bottom, but I tell you what, and we're only at 90 volts on the Variac. Although I probably should put a line voltage monitor on there going through the isolation transformer. I don't know if it gets bumped up a little bit, but that is very good. So some new caps in the vertical section took care of that problem. Now which one of these is the... That must be the vertical oscillator control right there. Looks like there's a dirty spot on it. Yeah. And then horizontal is that one. Okay. So yes, we have vertical deflection. Just curious. I'm gonna gently turn it up a little bit. I don't want to run it for too long at this with crappy old electrolytics in the power supply. I don't really need to push my luck too far. And I want to see how far. So there's maximum brightness. That's actually a decent amount of rotation. I'd say at about the halfway point on the control we start getting visible, which is a lot more than most of my other sets that I've worked on. So that's pretty good. Alright, we're about 100 volts there. I'm sure it's not super happy that I'm powering it up like this, but gaining width. And yeah. It's about 105. I think we're going to get quite a bit. Wow, that's okay, so that's maybe a quarter of a turn right there before we start getting light again. Yeah, this is going to do pretty decently, I think. All right. Of course, we still have the issue we need to clean that control pot. But, yeah. Excellent. See, this is going a little more smoothly than the 17-incher. I don't know. I seem to... I like the chassis layout on the 21-inch model better. I know it doesn't have an isolation transformer in the power supply or anything, but it's just so much easier to work on. At least from my perspective. Anyway, I'm going to keep plugging away at this, and I will get back to you soon. Progress report on the underside of the chassis. I have completely replaced the 4-section electrolytic here. That is now out. And get the terminal strip in like I did last time. I reused the self-tapping screws that I had from the other capacitors to hold this in place. I did have to grind them down a bit so they don't come anywhere close to the bottom of the PCB on the other side for safety reasons. And I did have to extend some of the original wiring to get up to here. This is all 600 volt rated wire. And just kind of cleaned things up in that region. Haven't done this one yet, just because with that done, I want to make sure everything still works. We got a raster last time. Oh, hello. And the inspector here is going to watch as we fire this up again and make sure that I haven't done anything stupid. Got the screen a little bit out of the way. So we'll bring this up about 50 volts. And see if most everything still works. Yeah, so we're still getting a raster. And hump there at the bottom is kind of interesting. There's some interesting noises going on in the back of the CRT there, so I'm going to shut this off because it almost sounds a little bit like arcing. There is an electrolytic inside that housing as well as a tube. And 1 or 2 paper caps, I think. So I'm not going to push my luck too hard here. So good, I haven't ruined anything, which means I can progress on. The last things to do on the chassis, at least on the bottom as far as that's concerned. That might just be all the dust burning off the tubes. I haven't wiped them down yet. They have an odd smell. Doesn't smell like burning necessarily, but it's just funky. Let's see, when I say, yeah, that's that electrolytic right there. We got to do that one. And then I have brand new power resistors to replace these 3 clusters of crap right here. I went back and I reviewed Bob Anderson's video on replacing the sand resistor on those units, and he did basically what I thought I should do, which is just go to the closest standard value and then make sure that the wattage rating was as good or better than the originals. I actually have those parts over here. Oh, and then of course I also need to replace the hockey puck right there, the thermistor for the filament circuit. Yeah, those are the SL12 22101s from, who makes these? Amatherm. Okay, so we've got 10 watt at 12 ohms. Got a 5 watt 8.2 ohm resistor, and then finally a 10 watt 18 ohm resistor. Tried to buy the good name brand, Sprague Vichet, Ohmite, that sort of thing. Now they're going to be a little, I think some of these are a little bit long. They're going to be a little longer than that, but I should be able to fit them into the same space. So this should pretty well wrap up the work on the underside of the chassis. I've got the new power resistors in place for the filament string, and we also have the SL12 whatevers over here for the thermistor. So that's in place. I replaced any resistors that were out of tolerance under here. The rest of them all checked pretty nicely, within 10%. And I think now I'm going to flip the chassis back over and shake any little bits of solder or trimmings out of it before I fire it up again to make sure that nothing went catastrophically wrong. We have a pretty good range of brightness control, but it seems like it tops out once it becomes visible. Either way, that's still pretty good. Still showing that we've got everything we want, at least for right now. However, there's some odd crackling coming out of the high voltage cabinet there. But I think I should go grab a signal source, and we'll see just if anything can get through, just for the hell of it. Ooh, the tuner is very, very dirty. Yeah, if I wiggle the shaft around, we lose signal pretty easily. Let me see. Horizontal's off frequency. Aha! And vertical? Well, we can... Yeah. It's, well, okay, it's kind of sort of locking, but we're getting ghosts. Yeah, let me hit play and see what we get. Obviously, I haven't done anything to the deflection board, nothing to the IF strip, but it is working, which is kind of nice. But do we get audio through? No, not really. Ah, crap, we lost it. I'm switching to the adjacent channels to see if maybe that picks up better on one of those, which it does not appear to. But it also looks like I'm going to have to dig into the tuner and clean all the contacts like I did on the Princess. Because we lost everything. Crud. Am I still on a menu? Whoops. Oh, we do have audio. But we have interference in the audio circuit coming through from somewhere. Pretty badly. Now, let's see. Ooh. Crank it up too far and we get all the release trace lines. Okay. Yeah, we've got a little ways to go, but it's a decent start. I'd say that's as good a start as any. The next thing I want to do is going to be to take the enclosure off of the back of the CRT because I need to get in there and replace an electrolytic and a few paper caps. And I haven't actually disassembled the entire housing on one of the big 21-inchers for that, or even the small ones for that matter. I've only done it halfway. But the only way to really get to all the connections is to take the whole shroud off, which is going to be interesting. Yeah, it'll give me a chance to clean the front of the screen off. And thankfully, the protector on this one hasn't gone all foggy like on my my Holiday, which every hour or so grows a brand new layer of gunk on it. And there's no fixing that, sadly. But this one seems to have gotten lucky. The chemistry is pretty stable. But we do seem to be having issues with the horizontal section. It's actually making a somewhat obvious noise. This flicker right here that you can see, you can hear that coming from the vertical output tube. It's rapidly ticking. So I'm going to shut this off because I haven't done anything for any of those paper caps that are in there yet, and I don't want to push my luck. But there we go. The Tandem lives. Got a little bit of progress done. And now it's time to get my hands dirty and tear apart the screen. Alright, thanks for sticking around, and I'll see you in the next one. Thanks for watching.